Welkom bij de derde Project Design Architecture meetup. Vandaag spreekt Campbell voor ons. Jullie kennen allemaal Campbell, hij doet .NET Rocks en heel veel andere dingen. Het is al 30 jaar software engineer en architecture. Take it away, Richard.
Thank you very much. And my Dutch is completely worthless. I used to go to the Software Developers Conference of the Netherlands way back when. That used to be out in Arnhem, which if you're not a World War II history buff is nowhere. No. And it was the Olympic Center, which is like go to Arnhem and then go further nowhere. That's where we were. But it was a lovely place. You couldn't leave. There was nowhere to go. And we had a lot of fun there. The main thing, we had the most important thing as speakers at SDC, it was the unlimited drink cards. You wear a speaker badge, they would just keep bringing you beer. And what more did you need? Eventually you didn't care where you were. So I missed that show. We had a lot of fun doing it. That's a lot of years. And it happened that in the early days of that conference, it fell on my younger daughter's birthday. And so while we'd always have a birthday party before or after, and I would call her the day of, it got to her that I missed her birthday repeatedly. And so I promised her, I think on her 9th birthday, I promised her, her 8th birthday, the next time this conference falls on your birthday, you can come. They moved the conference the next year. And they did that for 2 years. It's back. And then they did that for 2 years, and then they moved it back on her birthday. So for her 11th birthday, we brought them, we all came out, and she actually celebrated her birthday party in Arnhem, her 11th birthday, including they brought out a cake with sparklers that set off the fire alarm. And then we went to, after the conference was over and we did the tour in Rotterdam, we took the train down to Paris. And so the girls got to go up on the Eiffel Tower and have a little experience. And as it turns out, I brought her with me. So she's sitting right at the back and she can wave. She's not too horribly embarrassed. She's 19 now. So that's how I'm away for 3 weeks here. I did a week last week in Leuven, and now this is sort of the loose week. We're traveling around a bit, and then next week I'll be in Norway for the Norwegian Developers Conference. So I've had a basic introduction. I'll tell you a little bit about myself. That's my Twitter handle, and probably the easiest way to reach me if you want to communicate with me. Ping me there. I pay attention. I wrote my first line of code in 1977. So you let that sink in. That was on a TRS-80 Model 1 with 4K of RAM and a cassette tape player, 127 by 47 graphic resolution. I'm pretty sure I got these glasses from that terrible monitor. It just burned my eyes out. Had a version of BASIC not made by Microsoft. It was a Dartmouth BASIC that had 3 error messages. What? How? And sorry. Which I still think are the best error messages ever, because at least they're honest. I mean, what is object not found but sorry? You know, the only difference is back then, every byte counted, so it was all command line, right? You'd say, hey, print, divide 1 by 0. It'd go, sorry. And then it would be ready for the next command. Today, you know, modern systems like Windows make you agree that you're wrong. Object not found. Okay. There's no not okay button. I once had a neighbor come over and say to me, my computer says registry is corrupt. Okay. I want to press the not okay, but I can't find it. Can you help me? So it's not like computers have improved all that much. Admittedly, 1977, I was all of 10. My father's in electrical engineering, taught me electronics from a very early age. And so, but the obsession started right then and there. I lived in that Radio Shack and tinkered with that machine endlessly. I became a useful sales tool because if a 10-year-old could do it, clearly a 30-year-old executive can do it. And my first real job, my first part-time job at 12 was repairing those machines because I was good with a soldering iron and you broke them a lot. So it was a good job. I got really good at aligning disk drives back when you needed to do that. So I was quite popular as a teenager for my ability to align Apple II disk drives. I was fast. I could do them about 10 minutes flat, which when you charge $40 a shot is a lot of money. So I actually worked for the company that had the contract to align all of the disk drives for the school district that had hundreds of these things. And so over the Easter break, I take covers off and line the drive one after the next. And every so often you found unusual drives because when they knew they were going in for alignment twice a year, so if they broke one, they would just stick it on the shelf till the alignment came. So every so often, there was one thing you could do with an Apple II drive. If you missed by one row of pins, was off by a pin, it would actually short the controller and it would fry it. And that would kill the drive. And we had a little kit. I could recognize the fried controller every time. It took me a couple of minutes to take it apart. So I would just have kits to repair that. But every so often you got exotic drives. Like somebody kicked it down the stairs or something. You can't align your way out of that, right? Those are factory repairs. Like this drive is broken. Right? If you pick it up and it rattles, that's it. Just send that to the factory. So I'm not exactly sure what happened to this particular floppy drive. But I slid the 4 screws, slide the cover off it, and it was just green and fuzzy inside. My guess is that some kid decided to see if a cheese slice would work as a disk drive, and then it sat on the shelf for 3 months and just grew. So I take the cover off, and I look at the drive, and I put that cover back on. I go, that's a factory repair. That drive. Because I started so early, I was a hardware guy. You didn't have a choice. You have to learn your way around hardware in those early days, and I got to grow up with networking. I did thick ether, which was good fun, little drill, and tapping wires, and the thing basically wouldn't bend, and you had to measure all your distances, and timing mattered. I did ArcNet because it was cheap. So I remember networking before the RJ45 jack. I actually liked Token Ring, I just didn't like the plug. And apparently nobody liked the plug, and that's why nobody does Token Ring anymore. So as I became a professional and moved to this industry, the ability to work in networking and software and hardware made me a good diagnostician. And so I ended up making a living mostly on performance tuning work. Because it's hard, and you really need to deal with the interplay of systems most of the time. And I say performance work rather than just say making websites go fast, because while I've done a lot of that, I started early enough before the internet was really public. I actually made DCOM go fast. And if you've ever done that, you know the D actually stands for dumb. So as a consequence, I've sort of fallen, along the way into a bunch of different things. Consultancy is the obvious practice, being out in the field, helping different teams, because performance tuning is a fairly unique skill, and you don't get to do it every day in any given company. You end up floating from place to place, and folks value that a lot. Architectural work, certainly, the validation of any given architecture is putting it under stress. Making systems go fast is a great way to stress an architecture. So that ends up being a big conversation for me. It was after my second daughter was born that I started really taking my career seriously, and that led to environments like this, having a chance to talk to software developers and really study where industry was going. And so I did a lot of writing, and I've been involved in conferences literally for 20 years. And it was about 2 years ago that I actually started my own. So Dev Intersection is my best thinking about how to talk to software developers about where industry is growing and what we should focus on. I do those shows twice a year. In the spring, we typically do them in Orlando. So the last one was this past April in Orlando at the JW Marriott. And in the fall, in Las Vegas. So second week of November. And if you follow the podcast, you know who I invite to my show. So I have a pretty good roster of people. Any .NET Rocks listeners? Anybody? Just 1, 2? Okay, so they're podcasts. I did not invent them. I did not .NET Rocks. My friend Carl started it back in 2002, which is amazing because the word podcast didn't exist in 2002. He just took MP3 recordings of talking to his friends and posted on the internet, and we've continued that practice more or less. I came on board in 2004. I was a guest on show number 69, and this past Thursday we published episode 986. So we just about got it figured out. So 3 times a week now we put out a show, Tuesday, Wednesday, Thursday. The Tuesday show tends to be the most technical show, so I focus on a specific technology. I vary a bit. There's sort of flexibility there, but if you're just worried about technical content, you can filter out for whatever types of shows you want. If you care about C#, we've got a tag just for C# shows. If you care about application lifecycle management, we've got tags for that, and so on. So Tuesday shows tend to focus that way. Wednesday shows is our mobile focus. So back in 2011, we created a show called the Tablet Show because we realized that tablet mobile development was going to be really important. And back in 2011, that seemed like its own thing. But in 2014, it turns out tablet and mobile development is just development. So we rolled them back together, and that's why we have 3 shows a week. So our Wednesday show tends to be mobile, tablet, Windows 8, much more platform agnostic. We will actually talk to iOS people there and Android folks. I have a show coming probably in the next month on a Wednesday slot on Kindle Fire development. So I've finally found a group of guys who are building Kindle Fire apps and actually making money. Apparently, it's not very many of them. And they're willing to talk to us. So we'll be doing a show on that in the immediate future. Thursday shows range further afield. Career topics, sometimes in history. Like once we got Les Pinter to come and talk to us about selling Word to Bill Gates. That's just really interesting view on the industry. And once a month we do a show we call a Geek Out. So we ask the listeners, what do you care about? What's interesting to you in the world of geekiness? And do the research and publish it. So we've talked about all kinds of alternative energy, various space topics. The latest show published is on coffee, and I've done one on whiskey, which nobody should be surprised about. I think I did one on whiskey in one breath, as well as barbecue. I did a show on nuclear power, which upset everybody, because apparently I'm not pro-nuke enough and I'm not anti-nuke enough. And did one on nuclear accidents that I'm still getting hate mail for, which I'm fine with. And the other podcast, because I also exercise the IT side of my brain, is Run As Radio. So that's a weekly, comes out on Wednesdays, and we focus on IT-related topics. So if Exchange scares you, that makes you a basically sensible person, and we talk about Exchange there, SQL Server, Active Directory, things like that. But we want to talk about DevOps. Now, DevOps is not a word I invented. It really comes from the open source community. So the first time the word DevOps was actually used in anger was by a fellow by the name of John Allspaw. And at the time, this was 2009, he was the head of operations for Flickr, the now owned by Yahoo photo site. And he did this presentation at the Velocity conference in San Jose. It's an O'Reilly show. I've actually had a chance to present at it. It's not exactly a Microsoft-friendly world. So the way I ended up at Velocity was Steve Souders invited me. Souders is the guy who wrote Wiseflow, the tool used it through Firebug on Firefox, and actually give you a list of things of what's bad about your web page and how you can make it go faster. He now works for Google. So we had him on the show, and I said, Eddie's wonderful, like just a really smart guy and quite agnostic. Like he just cares about making stuff go fast. He doesn't care who runs what. He's not one of those guys. So I talked Microsoft into letting Souders present at TechEd, which A, caused a huge kerfuffle, and B, he killed it. Like just magnificent presentation. And I guess sort of reciprocity. Why don't you come and do your talk on web performance at Velocity? Velocity is a conference about web performance. The Facebook guys are there and the Google guys are there. It's all about making stuff go fast. That's what we do there. And I had this talk called Death of a Web Server. I've been scaling systems for years, and I finally figured out how to really do a solid presentation on scaling websites, because it's hard to do. You know, you need to run multiple instances of IIS and have a back-end service, and you want to do load testing and so forth. So I discovered these little 6-inch computers. They're made by AOpen, and I could fit 6 of them in a rollaway bag with all the networking gear and power supplies and stuff. So I could actually bring a little data, I call it a data center in a bag, bring this thing to a conference, set it up, lots of blinky lights, right? And we could do some load tests, and I could disable a web server, you could see it fail over. Like, it was really a lot of fun. So challenges with traveling with this thing, mind you, because I eventually called the bag secondary inspection, because that's what the TSA started calling it. Because it turns out if you pack 6 computers and all the power supply stuff in the bag, it doesn't matter how much you show them, they're going to secondary inspect the bag. I eventually came to the realization the correct way to handle this bag was not to take it apart at all. So, you know, if you've ever traveled in America, you've been through this ritual, right? You get up to the bins, and they always say you got to take your laptops out. They don't say you have to take your computers out. And each laptop has to go in its own bin, so you carry 2. You know, that's 2 bins. If they want to take the computers, I'm like, okay, I need 7 bins, which makes people angry. So I would leave that bag whole. First, take the clothes off. You need to take, you know, belt shoes to undress in front of the guy. Put that in the bin first, so you can get dressed before they see the other stuff. Disassemble your laptop bag as necessary. That goes through. Put secondary inspection through last. Now, quickly go through the metal detector. Start putting on your clothes. Just watch the guy on the machine. When he goes, you know, and you wait. Hi. I'll see you down there. We'll have a secondary inspection. Next, most important step about dealing with this bag was be really excited to show them what's in this bag. Wait till you see this bag. It's the best bag ever. Because a TSA guy can handle about a minute of that. And then you need to get away from me. You can go on your way with this bag. So I set up this rig at Velocity to demonstrate analyzing the performance problems in the web server and fixing them. Great talk, hour and 50 minutes. I got 500 people in the room like, okay, how many folks here are developing on the Microsoft stack? And I get no hands. I'm in San Jose, and this is not Microsoft country. All right. And I start the demonstration, walking through everything, thinking, well, maybe they've never seen this. And they hadn't. You know, we forget, as Microsoft developers, just how good our tools are. And I was displaying Visual Studio 2008, not the shiniest version of Studio ever made, but I was using the load test tools and walking the process that I could instrument multiple web servers and the database, capture the entire load test in one machine, then make changes, run the test again, compare the two. They'd never seen anything like it. I got a good stage rush at the end, guys coming up and saying, hey, can I use this with Apache? No, but thanks for asking. So back to the original story, John Allspaw is at Velocity in 2009, and he does this talk he calls 10 deploys a day. Because they had gotten the Flickr site to a point where they were literally publishing 10 new versions of the site every day, which is crazy for a couple of reasons. One of them is, this was 2009, not exactly the economic highlight of the planet, right? And so nobody really cared how fast your website was. But the other part was, how did they convince operations to keep pushing new software out all the time? And that was a really profound thing. He talked through how his development team and his operations team were working so closely together that they could perpetually be pushing updates to the site, small ones, but that effectively their testing was happening in production all the time. The side effect of this was, when you're at a normal cadence, something we're used to as developers, say you're agile and you're actually getting a build done every 12 weeks. Well, if you're an ops guy, that's not that often. That means if there's something seriously wrong, I got to wait 12 weeks for it to be fixed. They couldn't go for that. They were always afraid of deployment, and they wanted to roll back if there was a problem. But if you've got a build coming every hour, why would you ever roll back? There's another build coming. We'll just roll forward. And that's the story that Allspaw painted. The challenge was he was doing with the LAMP stack. In fact, every implementation of DevOps that I've ever seen in the field is very much a duct tape and baling wire process. They're building their own solutions. And it's one of the reasons I call this talk People, Process, and Tools. Because the most interesting thing about this is the culture it takes to make it work. First, we have to move the culture. Then we start talking about new processes that come into play. And from that, we can see tools that will affect it. Now, the problem with that is it's hard for Microsoft to sell because they're a product company and they want to sell products. And in fact, I'm already seeing ads for people that are making DevOps in a box. And I don't even see DevOps as a job. It's a movement. It's a way of thinking about how we build software. And if you're a serious Agilist, it's not hard to see that it's an extension of the Agile Manifesto. That while we were always including all of the folks that were building software, should we include everyone? Should actually stretch it further. So we get to this idea of actually extending the entire application lifecycle. Now, I hate the word application lifecycle because it means I have to show you a graphic, which I happen to have one. This one I hate the least, because there's many I hate more, because they often count, they're for other purposes, mostly about selling services. This one actually comes from Microsoft, and what I like about it is that it actually shows two clear, separate cycles that go on inside of organizations all of the time. Development has this cycle of picking up sets of requirements and sort of defining them into features, hopefully building some test plans around them, construction, and making an assembly ultimately to a package of a new version of software. And it hits this block down at the bottom here. Because there's another cycle going on. It's the operations cycle. And that operations cycle is focused on how do I take this package and put it out into deployment. How painful is that process? And once I get it out there, how do I keep it alive? How do I measure it and monitor it and control it? And hopefully have some feedback back to the organization about that particular version. And I've never met an organization that didn't go around this whole cycle. It was just a question of how quickly they went around it and how high quality the information was. When you start with requirements here and you end with feedback on the other side of it, it's no different than passing messages from one ear to the other and wondering why they become completely different. Often the only feedback mechanism I'm finding inside of an organization that gets back to development about applications running in production is an IT guy that wandered down the hall one time and said to the dev, "Wow, your software really sucks." You know, we would hope there'd be better messaging than that, more constructive information. How about a CTO who calls and says, "Why is the website so slow?" Is that the only feedback we're actually getting? How do we know more about how the app we built, how the requirements we gathered got manifested in the field, actually was seen by real people? And that's what gets interesting when you start really thinking about the life cycle. The first thing we need to do is address the culture that says that our cycle is this. It's just the left part of the equation. That once I've built it, I'm done. Let's go, right? I deserve a beer. Let's go for, we have shipping parties, not deployment parties. And that's a sin. Because if we actually care about building better software, it ends up mattering who's involved, and everybody that's involved in the software influences its success. And that's not just operations. It's InfoSec, it's QA, it's the product managers, and ultimately it's the customers themselves. How do we get them all involved, everyone involved, to build the best software we can build? Now, what does best even mean? We play this game of quality software, and I immediately ask for definitions. So what's quality software to you? And there's lots of different definitions that folks throw around. Stuff like easy to use. I like observable, because I've had that experience. I've built software long enough to have seen people use my software that don't understand what it's doing. Sitting with the lady who's been doing order entry for 20 years, and I gave her a VB app for her that looks just like the form she filled in from the paper, and at the very bottom of it, there was a button. And after she filled everything in, she pushed that button, and of course the hourglass appeared because we're writing to SQL Server 4.2, and that's going to take a while. And she says to me, "So now what's it doing?" Well, that was a great statement about observability. That little hourglass just doesn't do it for her. If you think about the UIs we're building or the user experiences we're building, how much of that is about observable behavior, that we see how people move from place to place, that it was jobs that was big on skeuomorphism, that we're giving it textures and so forth, but it's all about making it referenceable. I see that we flipped the page, which gives me a sense that I can flip back. That's what that was about. That's one element of quality. Now, I'm a performance guy, so for me, quality equals speed. Because if things happen fast enough, they feel more natural. But that's up to you. Quality is a very tough thing to get your head around. And I think the bigger issue here would be to actually measure the people that are using the software to see what their satisfaction looks like. And that's not an easy thing to do. And I think it's a part of a larger goal of, in our culture, we want to have higher quality software, which means we actually have to capture the truth of what's going on with our software. Now, none of these are original ideas. None of these are particularly special. We've been talking about software quality problems for 40 years. We've had issues around this all along. It doesn't matter what the tools are. Everybody wants better software. They just don't necessarily know what's going on. So why is DevOps now? The big thing that's happened with DevOps is that a whole lot of things that used to take a lot of time are happening much more quickly. So if there's any one technology that's brought this movement to the forefront, it's virtualization. Now, virtualization started, if you go way back, in the testing arena. So back in the Windows 3.1 days, we had these early versions of virtualization that we used to deal with installation problems, where we were actually able to have a static configuration of multiple machines, each different platform as we needed to deal with it, and we'd install our new app on that VM, see if it failed, which it did, and then we'd reset back to the beginning, we'd make some changes, we'd try again. It then moved to the server platform. As it got faster and the hardware got more responsive to it, when Intel and AMD actually agreed on a set of extensions, start interacting with VMs, suddenly the cost of the VM went way, way down. You know, in a testing arena, we didn't care that everything was slower. We just wanted to run the tests. But if you're actually going to put this in production, it was a fairly big deal. And you think about the hardware explosion we had in the 2000s, folks were trying to mitigate some of that cost, and virtualization let us use hardware far better. And that progression has continued. Now, I'm not big on virtualization on the desktop yet, but I kind of tell you it's coming. But you see what it's done in operations now. Suddenly we have this idea of configuration as code that I can literally point at a given server and say, make me an instance, and this configuration problem, up it comes. Now move it over to this machine, and it just does it. It's voodoo when you see it in action. If you've ever P2V'd a server, that's spooky software. I pointed at a physical machine, I pointed a virtual server and say, make that live there. I'm going to get coffee. You go away, you come back, and everything's still running, except that machine is now off. That's the sort of strength of virtualization. It started to change the way we've been thinking about it. It made infrastructure almost trivial. It's undermined operations. I remember when all of us were developers were doomed because they were going to outsource everybody, right? Then they found out if you make a bad plan and you send it to another country, you get a bad plan for less money, but you still don't get usable software. And if you actually came up with a good plan, turned out you could do it at home and still pretty happy with the results. So much for that. But same thing's been happening on the operations side. When we started virtualizing everything and automating a bunch of stuff, like what do these guys do all day? I worked at an organization, I got hired into an organization in Indiana. They had four, I'm going to leave out the names to protect the guilty. They had four major divisions. One of them was blowing out their numbers in a huge way. And they laid it all down on this beautiful website that everybody loved and how it was interacting with systems so well. Customers were super happy, and this VP was kicking ass and taking names. And so they had brought in me as an external auditor to review the designs and sort of capture the essence of what they'd done to be able to replicate it onto the other teams. And I sat down with the guy and I looked at it and figured out he wasn't using any of the company infrastructure. The whole thing was running in Amazon. He just bypassed the whole company. He hadn't told anybody, and he had violated all kinds of security-related issues, but boy, oh boy, was he making money. And it sort of pointed to a larger issue, which is as IT had built up this inertia, they become an obstacle to productivity, a massive one. See, I've done both jobs. I've been the dev guy, and I've been the IT guy. And the IT job's a pretty good job, right? Because you usually get an office. I had an office, had a door, put a sign on the door. It said, no. Any questions? Because I wanted to establish our relationship before we knocked. The problem when you're a really good IT guy, nobody can tell. You are invisible because everything works. And I get lonely. So I turn a server off. Phone rings every time. Hi, miss me? Let me turn that back on for you. How's it work now? Okay. But that was the problem with it. The best you can ever get as an IT guy is a C. It's easy to get an F, turn a server off. But if you do your job perfectly, nobody can tell. Now, when you're a developer, you can get an A because you ship new features. There are parties when you're a developer, right? There's shipping parties. There are no parties for IT people. Nothing crashed today. Let's have a beer. That's not a party, right? But developers building new things that are visible to the customer and to the internal organization, that's exciting. It's a big deal, right? It's also risky. You build, what's most likely to mess this guy up? That guy, right? He rolls out that new version. Just deploy it. What could go wrong? If all the customers became Nim John Smith, is it that guy's fault? No, it's my fault. Because I can only get a C or an F. And so there's a tension between these two groups of people for a reason. It's not necessarily a bad tension, but it can get that way. And it turns into this downward spiral that is so demoralizing. The downward spiral is that process where we've got to get this software out right away. So we don't have time to do it right. So we rush to get it out and we just deploy it. Just get it up there somehow. Deployments are always a nightmare. And then you're constantly firefighting to keep the system up. You know, if we just reboot this thing every hour, it'll keep running. That's awesome, right? Like, I've been there, right? Like, that's the answer. If we just reboot the server, well, we're running 5 servers, so if we alternate so they're every 10 minutes, at least one of them will be up. The load balancer can keep up with that, can't it? And as the software grows on this horrible foundation you've built with additional features coming on, development gets slower and slower, or don't work at all. And eventually customers get frustrated and they start leaving. And then what happens? Management declares a new version because everything you haven't shipped works beautifully. So they declare a new version, coming, version 3, every feature you've ever hoped, and it'll be amazing. And here's an arbitrary deadline that we'll have to ship by. So don't spend too long on this software, we better hurry. And the cycle continues again. This is a really tough way to work. And it ends up in that terrible finger-pointing game. And I've been in those meetings where a couple of IT guys arrive and a couple of dev guys arrive, and they sit across from the table from each other. And management comes in and says, okay, guys, we can't have another weekend like last weekend. I know you guys can fix it. And then he goes golfing, which is good because the worst thing he can do is actually stay in the room. Now, what happens between IT and development? Well, it's your crappy software solving a problem. If your network didn't suck, this would be fine. And we argue for a while and both agree that we don't have enough information to actually make a decision. And so we're going to have to meet again next week, which we now add to our Outlook calendars and forget until the 15-minute reminder where we start now pulling up log files and things so that we can actually have information to accuse the other guy of being wrong, and we'll do the meeting again. And it'll keep repeating indefinitely. How do you break out of the downward spiral? Actually build better software. And why is this such a big deal now? Because we've hit a point where it's just not optional anymore. And the axiom is this. We really talk about the essential parts of why the DevOps movement is coming where it's gotten to. It's that we're now in a world where software is the business. It's not a luxury. It's not an option. If the software's down, we don't work. The business stops, right? We're dependent on our websites. We're dependent on our messaging systems. We're dependent on our message buses. These things aren't for fun anymore. That's how we build our business. So if that is true, then there's no technology problems anymore. There's only business problems. We cripple the business when our software doesn't work. Simple. And it turns out that all businesses actually are is people. So if we can deal with the people, the rest will come. And that gets back to the essence of what this problem really is. It's a people problem. When the people are thinking the right way, when the culture is the right way, the processes will come. And from those, the tools make sense. It's all it is. Now, there are avatars, there are exemplars, there are companies out there that are proving this to be true. And they often have great quotes. Do painful things more frequently so you can make them less painful. That quote comes from Adrian Cockcroft. Netflix is the poster child of DevOps. Why? This company started out renting DVDs by mail. That's what they did. You would get a catalog and you would pick a movie you wanted to watch and they would mail it to you. And when you're done, you'd mail it back. What a dumb business. They figured out pretty quickly, if we don't get online, we're going to be done. And they knew they had to be in the cloud because there's no way they were going to build that infrastructure themselves. So they got into the cloud. And bit by bit, they made the most resilient computing system in the world. Why? Because in the United States, between 5 p.m. East Coast time and 9 p.m. West Coast time, Netflix is 25% of the total bandwidth consumed in the U.S. That's more than porn. How do you think they load test their systems? It's kind of impossible. There's not enough internet to go around. And so they've started to design in a very different way. Now, not all of us are going to have this massive scaling problem. Not all of us need Chaos Monkey. And Chaos Monkey is an open source library, part of what they call the Simian Army. You can go get it off of GitHub if you want. And the principle of Chaos Monkey is you don't choose Chaos Monkey. Chaos Monkey chooses you. The way that Netflix now tests their software is by running a service that randomly kills servers inside of their system 24 hours a day. And they don't go down. It's the only way they can actually validate the model. It does things they don't expect. That's the point. It's Chaos Monkey. Right? And so when Amazon, the service they supposedly depend on, had a complete West Coast outage so that none of their customers could be served, Netflix was still up. That was the proof. They outdid their own infrastructure, that their system was that resilient. Now, not all of us are going to be Netflix. It might be fun. And not all of us should run Chaos Monkey. but it speaks to a larger issue of how do we build the best software we possibly can, because there's big problems to be solved, and most of them aren't the battle between each other. They're out there, and if we can all get on the same side of that problem, we can deal with it. So we're all responsible for the success of the software, all of us. And so we can only measure that success in the entire cycle. We live and die together. So what does that mean? You still have shipping parties, but you don't have them when you ship the software. You don't even have them when you deploy the software. You have them after that version of the software passes a threshold of utilization by the customers. That's when you have the party. When everybody's using the software and loves it, have the party. That's the thing we need to break down, is that we're anything other than one team. Now, I know you're all in and you want to do this. So the trick is where to start. Now, Gene Kim, who's one of the godfathers of DevOps, breaks this down into 3 ways. They build on each other. It starts with the first way. You cannot convert your whole organization to DevOps on a day. It doesn't work that way. And management's going to try. The same way they did with Agile. The same way they did with Internet. Remember when Internet was a brand new thing and the boss showed up and says, we've got to get us some Internet. Like it came in a squirt bottle. We spray everybody with Internet. Things will be good. We could squirt everybody at Agile. The developers will build more software faster. DevOps is going to do the same thing if we don't own the term, right? You have to make incremental improvements, and it starts with 1 or 2 people heading down the first way. The goal is to understand the entire flow of work. So, and a byproduct of that understanding will naturally be an increase in the flow of work. Here's the trap that we're in today, and we allow it to happen to ourselves, and we complain about it. That often we're treated like cogs in a machine as software developers. Client developer, awesome. Okay, you fit here, and then we've got a back-end developer right beside you, and let's stick a DBA over here. Series of gears that all rotate together. You would never want to do anything else. You're part of the machine now, and so we expect you to understand the cog on your left and the cog on your right, and that's a trap. Because if we don't actually understand the whole flow of work, how can we get better? Until you can see the flow of the system and how it works together, you miss out on simple opportunities of improvement. Early in my consulting career, literally talking the 80s, I was the printer guy. In Vancouver, folks knew if you needed a special kind of printer, you're trying to solve a problem, because back then printing was a big thing. I was the guy who knew all the different kinds of printers, especially high-performance line printers. And so I get a call from a company, and they say, hey, we understand you're the guy who can find us a printer that'll go really, really fast, because we've got to print out our GL every year, or every month, and it's just taking too long. And I'm like, sure, I can get you, but a band printer with a soundproofing closet, $25,000 printer. That's a pretty serious printer, but it's stinky fast. Like, well, if you think that's the best printer for us, why don't you come and take a look? So I'm like, okay, I'm all in. I go and visit this company, and I'm trying to figure out why they print out their entire general ledger every month. Because that's a whole ream of ledger paper. Remember the old style paper with the tractor feeds on each side and the banded colors? One of those things. The entire box is being printed by a Nokia 2560, and it's taking like 3 days to print this thing. And they can't close out the month end. So you have to finish all the and it's taking too long. I'm like, well, what do you do with the GL? And it's one of those sacred cows. You don't ask what to do with GL. You just print out the GL. And I can't get a coherent answer of why they're doing it. So eventually I give up and say, I'm just going to follow this thing. So then I said, well, let's wait for the month end so I can actually watch how you print this thing, and then we can figure out what printer to get you. We've got a few ideas here. And so I watched this thing print out over 3 days, and it's a stack of paper like this. And it weighs 30 pounds. And this nice girl carries this huge pile of paper through the building. And I just followed behind her. And she gets to the CFO's office, and she puts it in his inbox. Doof! And then she leaves. And I just sat in his office and watched it. And eventually the CFO came in and looked at me. Oh, the GL's here. And he picked up the whole GL. He flipped it over. He tore off the last page with all the totals on it. And I said to him, hey, is the only thing you need that for the total? He goes, yeah. He says, if I could print out just the totals for you, would that be okay? Says, you could do that? I did not sell a printer to that company. Following the flow of work around, and now we're talking about software development. So following how the work works inside of your organization. Ultimately, you want to educate everyone, but it starts with at least one. Because if you can see all of the steps and what it takes to actually get software in the hands of your customers, you're going to see issues, and the flow of work will naturally improve. Now, that's an overall picture of the first way. Start with systems thinking, and we'll talk about the other ways as we go further along. But to deeply understand your systems, the first is, what is the work we can't see? So the simplest starting point is just documenting all the work we're actually doing. So what does this look like? It'll tend to break down in 4 categories. And actually, the method of documenting it doesn't matter. So again, I'm starting with culture here. We need a deeper understanding of the way our systems work. Now let's talk about a process. I want to document all of the work we do in the organization around building software, everything. Finally, you can talk about a tool. My personal favorite approach to this is a large whiteboard and Post-it notes. And I'll tell you why. You're going to find out there's 4 kinds of work going on in the IT side. The first is business projects. Those are easy. Most everybody already knows about them. Most of the time, I can go in an organization and say, what are the major business projects that are going on today? What things are being built? Because they're features. They're new versions of apps. They're key products. And everybody knows about them, whether they work on them or not. Why? Why is that true? Why are business projects so well known? Because they have managers behind them, and managers don't do real work, and so they have to make noise. I say that out loud, okay, that's a shame. No, they have budget. And in order to get budget, you have to have a story, and you have to share the story with people. Right? You got to be out there banging the drum about what we're building. We're building version 4. And it's got a $250,000 budget, and it's going to do all of these great things. And that's how you justify its existence. I'll tease them every day about it, but the reality is that's what it takes to get those things done. So those are easy. You can usually list them out, and they're small. There's usually not that many. You know, most organizations, when we actually started filling it out on a Post-it note, sticking it up on the board, gave them a particular color, it took a very small corner of that board. The next were internal projects, and these are often known pretty much for the same reason. If it's got budget, it's a known project. You had to explain it to someone. So it's got a documentation chain, and it's clustering a database. It's a new source code control system. It's new testing infrastructure, stuff that we should make us better, improves our overall infrastructure. It could even be a new billing system or new time card approach. I mean, those are all internal projects. They tend to have budget. They tend to be known. There's probably a few more of them. There's still not a lot. It's the second half that's the big one. And the challenge is capturing it and showing it. So first off is changes. Everybody makes changes all the time. The phone rings, they ask for something. The quickest way to do it is just do it, and you do it. And often the folks that are making the changes aren't particularly visible in the organization. They're IT guys in the back room. Sometimes their changes are a big deal. I was doing an audit of an infrastructure for a new version of a system down in Silicon Valley. Fun project. We're going through the new design. There's 2 days into it. And in the middle of the day, everything goes, the site's down, right? And it's the usual thing. Phone rings, someone picks it up and goes, really? And just sort of yells out, hey, apparently the site's down. Because we wouldn't have alarm bells or anything for the main thing this business actually does for a living. That would be no fun. Gets off the phone. Everybody tries the site. Oddly enough, it's down. And now the panic starts, right? The ops guys are trying things. They're making phone calls. They're talking to the ISP, and they're connecting to external sites and trying to ring in, and everybody's hitting refresh just on the off chance it comes back. And about 20 minutes into this night, and I'm having a good time, right? Goes, oh, good, we got a firefight going on. Like, first off, don't change anything, because any changes you make now is just digging the hole deeper. Let's actually look at what's changed, work our way back. And sure enough, this guy wanders out of the back room and goes, hey, what's going on? Says, hey, we've been out. How long have we been down? 20 minutes. He goes, huh. Comes back in the back room. Whole site comes back up again. I saw that guy. I'm like, excuse me for a minute. Go in the back room, sit at the desk beside him. So, what's changed? Nothing. Changed. And he had a change request. Perfectly ordinary thing. He thought it had no interaction, but nope, it blocked us from being able to log into the server, and that was it. The site was down. He just undid it. And now he was going to figure out the correct way to fix it. So I started giving each of those guys stacks of Post-it notes. 2 kinds. right? A yellow one and a red one. The yellow ones were for changes, and the red ones were for outages. So when something's actually broken and you're fighting the break, you get it back up again. Just write down what it was. And maybe once or twice a day, we go and put the Post-it notes on the board. And at the end of the day, and at the end of the week, we just looked at the board. What are we spending our time on? And pretty quickly, we discovered lots of changes, lots of unplanned work. We didn't have a culture of CAPA, of this correction action, preventative action. We didn't do real root cause analysis. Why? Because it's talking about failure, and people don't like that, right? It's one of the things that slowly came out of when we started defining work was, hey, we're really afraid of failure. We don't talk about it. And so we keep making the same mistakes over and over again. Most interesting that happened in the week is how many times the same outage occurred. We got the stacks of Post-it notes for that fix. So also when we realized that every single time we did a build, it caused an outage. There was just some server that was misconfigured. But the guy who fixed that misconfiguration, he didn't know it was a misconfiguration. He's not involved in the build. He's an IT guy who dealt with the privileges on a particular server. It was configured wrong. So he just fixed it. We also realized he'd been fixing it after every single build. And when this guy went on vacation, nobody could do a build. But a small fix. Hey, all these Post-it notes go away if we actually correct that privileges problem. So it was visibility into these problems. No plan, just visibility. That when the dev guy stood beside the ops guy, wow, you spent a lot of time on that. We started talking about fixing them. You know the guy who was really impressed? Director of engineering, senior management. They came down, saw this huge burden. What is this? This is what we do every week. And what's this? These are the main projects. Of course, you should be spending all your time on this. There's only 8 of them, right? There's 300 Post-it notes on this board, but there's 8 of those, and there's 12 internal projects, and everything else is technical debt. That's what it actually is. We manifest a visualization of technical debt. It's all of the change requests and all of the little outages and all of the fixes that we do every week. And devs only use a tiny part of the time on this, but they're really distracted. Because the problem when you're a developer is that focus is everything, right? That's why we tend to work late, because it's fewer interruptions. When I was a developer, I measured my productivity in interruptions per hour. And the correct productivity level was 0.25. I needed 4 hours of uninterrupted time to actually write software I was proud of. Because it takes about an hour to pick up the threads, to open the code and remind yourself where you were and look at the work item and think, what the hell was he thinking when he wrote this? And then look at the code you wrote and go, what the hell was I thinking when I wrote that? But finally it comes back to you. You know, you sort of get it lifted up and you start into that cycle. I write a little and I run a little, and I write a little and I run a little. It starts to do something. You know, the service starts to come to life, the screen starts to render correctly, and an hour goes by, another hour goes by. Finally, you've got something built that looks like the work item. You're 3 hours in, and now you know you're going to have to check this code in, and you haven't followed any of the coding standards at all. So it's going to take another hour to actually be code you'd be willing to show anybody. So you maybe do refactor a couple of things to tighten up, and finally you get to a check-in. And you know as well as I do, if you're interrupted at anywhere along that path, throw out the whole hour. Start again. So I started getting into these work patterns as a developer because it was all meetings, right? If I showed up at 8 in the morning and started coding, maybe by lunchtime I'd have something. But probably not, because there's phone's going to ring somewhere in that stretch. And heaven help me if I look at my email. But after lunch, it's meeting time, right? You have lunch, and you got to talk to this guy, talk to that guy, and what about this? And why isn't this code written yet? And eventually I figured out, come to work at lunch, then go to lunch. Then do your meetings, and somewhere around 6 o'clock when the noisy people leave, start writing code, and you'll get a check-in about 10 o'clock, and feel good about it, and then go home. And you'll show up at noon. You know this guy, right? That's what the productive work looks like. So then you start looking at this. Every time the IT guy has a problem, he has to call that dev. And you wonder why he can't get his feature built. Because as long as the software is running, he's got 2 to 3 phone calls a day, spaced evenly throughout the day, so he never gets an uninterrupted block of work. And the more we added new version software, the worse the board looked. So once we had that visualization, we knew what to do, and we knew how to argue to management about it too. And if you want to scare management, have development and operations on the same side of a problem. Because they're used to you guys fighting. So when you both say, this is the problem, like, yeah, don't hurt me. Right? You have a chance to start that. Now, there's lots of other ways to document this. You can do this in Project. You can do this in Excel. You can use Trello. Use tons of tools. The tools aren't the issue. The real issue was, are we capturing everything that's happened? I like the Post-it notes because most of these guys couldn't leave their desks. They were constantly answering phone and fixing things. And if they had to go to a tool or something, they just wouldn't do it. But a Post-it note just sat there. And so they wrote on it, peeled, and then took them all up and filled the board with them. And then we started talking about, is this the best use of the time? If you're going to make changes in this area, should we have a change control management process around this? Or, hey, this guy owns unique knowledge that nobody else knew about until we put the Post-it notes up. Should we make sure somebody else knows what he knows so he can actually take a vacation? Actually take a break? And strangely, we got into this real culture of not only do we want you to take a break and not be buried, like be punished for coming back from vacation, we wanted to move your project, your piece forward while you were gone. It was a gift. That was our goal. You get back from vacation, let me show you the gift. We got these things done for you. That culture of wanting to give everybody who got a break a gift did two things. First off, everybody knew other pieces of code. No one person knew any one thing. And people actually relaxed on their vacation. They came back energized because they weren't dreading their inbox and they weren't dreading the fact that their project hadn't moved for 2 weeks. This visualization helped us to just move forward on those were the problems. And we could actually see the decay in the system, right? And the system was not the software that was decaying. It was the process we had. So, few things we started realizing. There was a whole class of problems that were occurring because the development environment and the production environment weren't the same. They happen all the time. We could actually see now that they were happening and what they were. There was a bunch of things we could do. And this led to an interesting idea. The only environment that actually matters is the production environment. Where the rubber meets the road, where the software touches the customer, that's the production environment. And we can run in any environment we want as developers, as QA, as InfoSec. Any other people can run any environment we want. The production environment is one that matters. Why wouldn't we run in all the same environment? So I started doing development in virtual machines. The same configuration as the production VM. It may not have as many cores. It may not have as much memory. But the configuration settings were the same. The simplest one to point at is the state service in ASP.NET. If you set up a development machine, bare metal, off the cuff, not even running IIS, you're just running HTTP6, hey, state service is in memory. That's the default. Why would you change it? And you know the production environment's out of process. So you build stuff that's not going to run in production. You have this great scramble. Hey, I checked it in, ran great on my machine. Well, I don't know what your problem is. And we have to untangle that mess. But if you were working out of prod the whole time, you'd never know anything else. You would do the right things from the outset. The bigger thing that comes from actually working from a VM model is production owns the configuration. You need to introduce a new library because you need to support a new feature. Totally reasonable thing. In normal development methodology, you just install the library and start writing code. And get committed to that library. The first time Office is going to find out about it is when you bring on the new build, right? But what if you can't add that new library? It has to be added to the VM so you can bring an instance down to you. You have to have the conversation at the beginning. Guys, got this new feature, needs this library. Take a look. And now they can make an assessment. Is this going to interact with something else? Does this fit with all of our policies? Is this going to work? Adds it to the VM, off you go. That conversation saved you this many Post-it notes. When we find out later, it does have a bad interaction with the production environment. It is in violation of InfoSec policies or any other number of things that can happen. First came the culture of I want better quality software, and I think having everybody involved does it. Then the process of recognizing we need a common environment, that we want to work in all the same things. We can build it ourselves, but now we're starting to see tooling. So even Microsoft started to figure this out. There's a new product, there's a new set of tools just released, it's an SDK, called the Microsoft Azure Toolkit for Windows Server. or Azure services for Windows Server, because somehow Microsoft makes the impossible name. What is it? It is self-service VMs. So it's a tool for capturing templates of VMs and allowing people to log into a site and create them for themselves. It was originally meant, Microsoft wasn't going to just publish this, it was going to be for ISPs to start running their own infrastructure more like Azure. So you could launch VMs for customers, you could assign accounts to it, and all that good stuff. But I'm seeing folks now saying, hey, you need a VM for testing, you need a VM for development. Here's the set of templates. You don't have to talk to me at all. Just fire it up. Only when you need to change them do we need to have a conversation. Make as many as you want. We've got a set of policies for auto cleanup. You can back them up. Hey, you're working on 3 different projects. There's different VMs for each of your products. No more DLL interaction. No more version problems. Keep them separate. So the tooling's starting to come. You just need to know about it. So you could roll it yourself. The longer you wait on this one, and it's just a whole class. It's not all the bugs, but it's a big class of them. It just takes that pain down. There's another piece of this, stuff like just getting to a common source of truth. This is what comes out of the first way. You work your way all the way through the process. You actually see how software is built and used. Okay? And all I'm asking is to look. Don't change. Look first. Because the obvious ones will show up. We always have our own sacred cows in our given org. Right? In your team, there's a sacred cow sometimes. Ops has sacred cows. But when we start walking through the whole way, we end up pointing each other's sacred cows along the way. You guys, you know this is a cow, right? But we don't talk about it, right? Same way that we print out the whole GL. We just don't talk about it. But when we start looking at what's going on, you start just pointing at them and go, I'm new here. I don't know a lot. It's fun part about being a consultant. You get to do this. Just like, well, I don't know. I just got here. That's a cow, right? You guys all know. Did you want it to be a cow? And then we start changing things. And the byproduct of changing things are going faster. One of the biggest ones you'll find is this concept of one source of the truth. That the source code and the configuration and the environment all live in one place. That a package represents all of those things. And one of those things you need to include in that is the data schema too. The database is not exempt from really clear management. Now, admittedly, the data must be cared for. There's a reason DBAs are grumpy all the time, right? They're protecting a set of data that apparently none of us care about, because we can just replace our stuff. They can't replace their stuff. And often DBAs, the experienced ones, the ones with scars, they are actually the owners of scripts, right? That, to them, is the secret sauce that DBA brings, is the change script. How do I make that version of the database look like that version of the database without hurting anybody, right? And first problem is there's not version numbers in databases. So you have to come up with a weird way that you figure out, okay, well, if that constraint's in place, that means this is a version 2 database. If it's not that, because that constraint is missing, but this column's in place, that's a version 1 database. So you run this version of script or that version of script against the version 3. Not that any of that would ever go wrong, because my scripts are bad, right? And building the backout script is an impossibility. But as it turns out, if you really study the data, you start to understand what was the actual issue. The actual issue is we need to move from schema to schema without being destructive to data. Turns out, tools for that, right? But the process here was I need to be able to move from version to version without damaging data. That's a very loaded sentence. I have now summarized the essence of what keeps DBAs awake at night. But when you can sit down and look at tooling possibilities and technique around this, you find out there's solutions. And that owning the script isn't the issue here. Owning the schema is the issue. And being able to do real testing on data schema and testing on script application, stuff that a lot of DBAs just can't do because they didn't know it was even possible. Right? They've been living in a world where the database is in a holy shrine. You have to wear a white lab coat to get close to it. Or maybe they're the typical DBA, what they call the accidental DBA. Hey, you were standing close to the server when the last guy quit. You're the DBA now. Congratulations, right? And he doesn't necessarily know any of these things. So we have this culture that believes we want one source of truth. We're trying to create a process in place that captures all of them. We've got to include the data in that so that everything is in one place. Our release process has to be almost trivial. So simple as you could do it by accident, right? I mean, for a long time, we used to have a build master. He's the guy who knew when to sacrifice the chicken to get the build to work, right? How do we get to one button click, it works? Just not a big deal. Because as long as it's a big deal, only the best guys will do it, and it will always be hard. How do I get my B team to do it, or my C team to do it? So part of my career, I worked in banking services, mostly offshore work, and I worked for a company, a bank, that had their main data center was in Bermuda, which is a terrible place to go. Don't ever go. That's not true, actually. It's very nice, unless it turns out the real Bermuda Triangle is the path between your hotel, the office, and the bar, because there's nothing else to do on that island. But they also had major offices in Cayman, and so they wanted to build another data center in the Cayman Islands. Now, they're both in the hurricane zone, so you think that's kind of dumb, but they're both English protectorates, and they both are tax havens. So for the business they were in, this was a requirement, and it turns out they're in different hurricane zones. One is the Atlantic belt, and the other one is the West Caribbean belt. So they don't get hurricanes at the same time. So we were built symmetrical data centers. Either data center could run the whole system. So if there's a hurricane coming, you just transfer the work over to the other site and let the hurricane go through, clean up the mess, you'll be able to transfer back. Now, we actually had a disaster recovery system that had to work. So we really tested it. And whenever you tested it, all the best guys in the organization, the A team, would show up to run this thing. It was a big deal to do a failover. And I'm sitting with the CTO talking about the fact that we've gotten failovers to work, we've gotten failbacks to work, we actually believe this thing's symmetrical, and he's still not happy. I said, why? He says, because the A team isn't always available. What happens if we have to do it on short notice and I can't fly you and everybody else in to make this thing happen? How do we make it so that everybody does it? And so I tapped my inner Adrian Cockcroft, and I realized we have to do it routinely. It has to get boring. So we started failing over every month. And every A team showed up for the first 3 months. And after that, they started thinking, this is boring. I'm not coming to this. And the B team started doing it. And then the C team started doing it. So after a year, everybody knew how to switch data centers. It's just not a big deal. That's one of the side effects of increasing the rate of build. We start building more often, it gets boring. And you have to automate. The only way to make it possible to go faster is it has to be painless. You keep doing the painful thing until you just can't tolerate the pain anymore, and you'll figure out how to eliminate the pain from it. That's what it really takes. Everybody can do it. It happens routinely. If you're doing continuous integration, you're doing it when the check-in happens. But can you go all the way down the path? Can you actually get to this is deployable when the code checks in? That's continuous delivery. And that's harder because that means testing is automated. And you trust it enough to hand it to an ops guy and say, you can deploy this. You trust your testing that much? That's a long way down the path. But the byproduct of all of this, I haven't done anything magical here. I've just looked at everything and seen opportunities and made some small changes, is that the rest of this starts to go faster. You don't need to go faster, but you could. You have headroom. You're not battling to get to delivery point anymore. You'll also find when you study the whole path that the second way becomes apparent. And the second way is more feedback. Feedback loops. I need to understand more about what's going on in my system to actually get any better now. You pluck the low-hanging fruit by looking for things. Now, how do we keep getting better? And there's a lot of different kinds of instrumentation we're talking about. A big one is instrumenting the development process itself. How long is it taking us to fix bugs? How long is it taking us to detect them? When I started instrumenting that well, I started noticing something. The sooner I could get the bug back to the developer, the less time it took to fix it. And that started being measured in minutes. So I'm trying to justify a fast testing framework because most of the time our testing hardware is the cast-off development gear, right? Or the cast-off QA gear. QA guys are running their own tests. When you actually want to automate tests, it's usually crappy gear you're putting it on. And it was taking hours to run it. And I've been a developer. I know there's a simple process, that 4-hour window. When you actually finish and you check in that code, what happens next? You stand up, you sing, I am a god. Then you got some code checked in, and you go get coffee, right? That's what happens. there's a window now of about 10 minutes. If I can get how you broke the build back to you before you get back to your desk from coffee, I win. Because if it takes an hour, what happens? You're checking your email, you're checking Facebook, you're forgetting what you just worked on. If it takes a day, I might as well hand the bug to anybody. It's like, dude, that was yesterday. I don't know. Look at the But if I can get it back to him in 15 minutes, he sits down with the bug and goes, oh, yeah, duh, and fixes it because it's still in his head. That's what instrumentation did for me. When I started instrumenting the development process, started saying, how long can we detect a bug in our testing infrastructure? How long does it take to get it back to the developer? And immediately the quality of software started going up and I could go faster. Right? I started spending more money on it. Today, we don't need to anymore. Today, I can actually switch. You want to understand why you do testing in the cloud? It's because I can light up 40 instances, split the web tests across all of them, run the whole thing in 10 minutes, which costs me $1.50, and then feed the errors back. Tear the whole thing back down again. Automate that whole process. It is awesome to watch. All these things rev up. All these tests get run. And now, my QA guys are pretty excited because you can start doing broader and broader sets of testing. You just launch more VMs to run it. So it's just not that costly anymore. And if you have a Microsoft MSDN subscription, you get a bunch of Azure time, and that's actually what it's for, is that kind of testing. There's more to understand. Lots of people are using TFS. How many folks are using TFS? Well, I mean, more than half the room is using TFS. A lot of people use TFS just as a source code repository. They don't really dig into everything that TFS can tell you about what's going on in development. Because the problem with interrupting a developer to see how things are going is it's like yanking a flower out of the ground to see how the roots are. You can do it once. But gradually, you pretty much know how the flower's going, don't you? Right? When I was managing developers, I was watching the fact, happy developers all look the same. They check in early and often, right? And they keep jumping up going, I'm a god, and getting coffee, right? That's a happy, productive developer. When I didn't see a check-in the whole day for the developer, I didn't have to bother him. I didn't have to look over, you check in yet? I don't need to. I can see it. System's telling me when he's checking in. Day goes by, hasn't checked in a thing. Another day goes by, hasn't checked anything. By the third day, are you thinking that like on day 4, it's going to be the best check-in you've ever seen? Or is he actually smashing his head against the keyboard? Or that stare, that 1,000-yard stare? James Joyce said the process of creating poetry is staring at the page until blood comes out of your forehead. I've seen that stare in the code. Right? So as a manager, I was pretty good at using the tools to actually see, maybe this guy does need to be interrupted. Are you thrashing? Like, how's it going? Maybe we can get some help. Talk about this. So starting to use the tools around the development process could actually tell me how my development process was going and were we actually getting better. There's a huge topic conversation there. But there's also the side of instrumenting apps themselves. Because today we have tools that will instrument in production and not significantly impact performance. There's a bunch of them. Right? So there's this idea that lots of folks build logging. The problem with logging is that IT controls it. And they make no mistake, all IT guys collect and keep logs. They zip them up and stash them away to be used as evidence against you. Okay? They never share them with you until you demand them. In the old days, I said, you got to get the production logs. But when you asked an ops guy, hey, I need the production logs, what did he hear? I need access to production server. So his answer is no. And you should agree with that. You never want to be access production servers because then it could be your fault. Right? You just want access to the logs. And since you know they're backing up the logs anyway, get access to the backups. Okay? And if they won't give them to you, they'll usually say at that point when you've harassed them enough, just ask me for the logs. I'll send them to you when you need them. And then I just put into Outlook at 8 a.m. every day, remind I need the logs. And after about a week of sending you an email every day, like, if I give you a username and password, will you stop bothering me? But today, logs aren't enough, and logs aren't even necessary. There are better tools for instrumenting applications. Some of them are free. We all have Visual Studio, yes? 2010, 2012, 2013, any 2008? Yes. Oh, there's no saving you, man. So 2010 and above, there's a product that comes with Studio called Preemptive Analytics. Have you heard of it? Preemptive are the guys who build obfuscators. So if you've never obfuscated code, you may have never looked at it. But underneath the obfuscation tool is a tool called real-time intelligence. And what it actually will do is interleave your IL. You don't even need to recompile your app and instrument the app. It'll actually measure what methods are being called, how often they're being called, how long they're taking. So it's almost like method profiling, but it's got almost immeasurable impact. Now, I'm a guy who has stressed web servers to the absolute limit. A strange loop we had a sign that said, I kill web servers for fun and profit. And I have killed a lot of web servers. And I have watched preemptive analytics with me running the web server right at the edge of doom, right? Like circling the drain. And what will actually happen is it starts running out of resources. It'll stop sending the messages of what it's taking its time on and ultimately just cache them or even throw them out rather than impact the performance. So preemptive is pretty good for this. And it's in your box. And you don't have to tell ops about it because it just comes in the DLL. It's just part of the app. But it will now start giving you feedback about all of the methods that are being called and also what errors occur. So often we have production errors that are occurring that we don't know about because ops has to write them up. And ops writes lousy bug reports because they're ops guys. The software didn't work. You'll ask for clarification. The software didn't work at all. And they only report the one. They don't report them all. So, hey, let's instrument production and capture all of the errors so that we actually know the important ones. And this is not that far out an idea. This is what Dr. Watson's about. Right? This is what CEP in Windows is about. The reason they were actually able to untangle the mess that was Vista was by looking at all of the errors that were being fed back by all of the machines that are running Vista. I don't know, both of them. And figured out that it was NVIDIA video drivers were crappy. And so what did Microsoft do? They went to NVIDIA and said, we'll fix your drivers for you. And you use the Microsoft reference drivers instead of the NVIDIA ones, and voila, your system started crashing a heck of a lot less. Didn't save Vista. We eventually got to Win 7 over that. But the point was there. Know what to work on. Instrument everything. Another example, Internet Explorer. They instrumented IE8. And they found out some interesting things. How many folks here use bookmarks in any browser? Bookmarks. All of us, right? Pretty much. You know why? Tech people, right? What Microsoft found out when they instrumented IE8 is that only 5% of their users use bookmarks. Mortals don't know how to use bookmarks, don't know what bookmarks are for. Most mortals haven't figured out that they ripped the address bar off 2 years ago, and they've been typing URLs into the Google search bar, so the Google gets the search credit, and then they get to click on the link of the thing they already typed in, right? So what did Microsoft do with this little tidbit that most people don't use bookmarks? They didn't work on bookmarks. IE9's got exactly the same bookmark engine as IE8. Because why? It's 5% of the market, right? The bookmark engine is good enough for you right now. I mean, the other way they could look at it is, hey, let's just do a really advanced bookmark engine because it's only for smart people. But the point is there. You look at how people actually use your software, you'll fix different bugs, and you'll change the way you build features. And the tooling's there. If you want to spend money on it, that's fine. New Relic, App Dynamics, there are great tools. They were intended to diagnose bugs, which certainly is a good thing. But you start going down this process, you're going to run out of bugs in a big hurry. Software's going to start working a lot better, and the interesting feedback comes back. How are people actually using my app? What did they care about? What are they spending their time in? And you can start feeding features ideas back to the product managers. So I got into a habit when I was running large-scale systems that I would always ask for logs. Right? I want those logs. Why did I want the logs? Because the logs tell me the truth about how my app's actually being used. And where that got interesting was after I shipped the new version. Because most of the time when a system has a catastrophic crash, we go back and look at the log files, and you can see weeks of the system saying, I'm going to die real soon now. I just wanted you all to, anybody listening? We all listen after the failure. So I was very conscious of the fact that when we ship a new version, the whole system's in danger. I know it's running, but is it safe? And so you'd watch the log files. And I'd do two things. One is if we could clearly see that something was degenerating, let's fix it before it actually takes us out. But the other one I'd do is I'd write this report up. Hey, remember version 2? We shipped it 2 months ago? Here's how many people are using the new feature. Here's how they're using it. Let's go have a party. Like, that's a real thing to celebrate. How are people actually using the new features? Are they using the new features? Should we be educating them? Is it only a certain group of folks that are using that feature? Did we build it in a way that's not usable? Are they using it in a way that's completely different than intended? We should redesign it. All of that is available in production level instrumentation. It's all there. You just have to ask the questions and capture it. So the side effect of the first way was understanding we didn't know enough about the software and how it was actually being used. So second way is about learning more about how stuff's actually being used. Our development environment, how we build the software, how we monitor it, and how we measure the apps that are in the field. The more automated, the better. Why? As soon as someone's handwriting a bug report, we can argue about the writing, not the reports. The preemptive analytics is picking up a crit level 1 bug that appears in the registry and feeding it directly back to TFS, which it can do. So can System Center Operations Manager. So can New Relic. So can App Dynamics. They can create work items in TFS. So you no longer have to go looking for logs. You're going to get them. And you're going to see consolidation. This thing happened 60 times on Saturday. That's useful knowledge, right? Plus, now the screen is the enemy. Biggest thing I can do when I'm sitting across the bench from IT as a developer is put something on the screen. Because as long as we're not looking at each other, we can't make obscene gestures the others can see, right? We are actually looking at the error that occurred. Here is all of the knowledge available about what happened. Not who wrote it, how they wrote it, how they didn't explain it properly. That's what happened. What are we going to do about it? Sometimes we get into environments where there's so much antipathy between operations and development, they won't even answer the phone. They certainly won't show up to the meeting. How do you get past that? How do we actually start this conversation? And it comes down to quality of communication. And quality of communication works up in tiers. The lowest quality of communication you can do right now is instant message. Instant message is, and Twitter is just instant message to everybody. So they're both low quality communication. If you've got an interaction of more than 3 or 4 messages with someone in instant message that isn't going well, change the medium. Switch to email. That's the next logical point. Now, email can degenerate pretty quickly too. If the number of paragraphs in each interchange of the email is going up, it's going wrong, right? Emails should get shorter over time in a conversation. They should end with okay, right? That is the correct email. Now, this conversation is finished. We're down to okay. But no, I send an email saying I'm having this issue and I explain it in 2 paragraphs. He comes back with 6 paragraphs. I work through each of his points in 6 paragraphs. He comes back with 40 paragraphs. This is not constructive communication. So we change the medium. Get him on the phone. That doesn't work, you have a meeting. And if that doesn't work, you move to the ultimate form of communication, which is pizza. Humans are hardwired to relate effectively with others when we break bread. It's built into our mind. In fact, if you're a leader of any kind of team at all, and you're wasting lunch, lunch is the most powerful point of communication you have in your workday. Look, this is about building trust. Trust within your team and trust within the larger team that we work in. When we're doing work, we're not building trust, we're testing it. We're seeing where it's at. It's very hard to grow trust. You have to do it away from work, especially when trust levels are low. And for most of us, the only time that we're not at work is lunch. So make it a plan that every lunch hour you know what you're doing. Talk to someone that you need to grow trust with. Probably not your team. You've probably already done it because you've been having lunch together for a long time. And you've talked about your families, you've talked about what's important to you, and they know now, and they trust you. And they've challenged that at work all the time. You got that bank account built up already. Go have lunch with the IT guy. Go have lunch with a product manager. Go build trust where it needs to be built so that when these conversations come along, they work better. Now, if you want to do after-hours things, feel free. Just do after-hours things that people can actually relate to. Trust falls aren't one of them. For most people, you like road courses, fine. You want a dirt bike, awesome. Maybe it's a World of Warcraft tournament. Whatever it is, the reality is that trust is ultimately the commodity we need to grow to make this work. You have to find environments to do it in. And that's not an easy thing to do, and it can't be done quickly. There is no difference between exercising a bicep and exercising the trust between 2 people. It can only be done a few times a week for a short amount of time, and it has to be done over time. There's no other way. Until we get to that point, we can't talk about this stuff. first way is an interesting way to start constructing trust, because we do start walking around and seeing each other's problems. That moment in front of the board where everybody's standing there where you're like, dude, I can't believe how much work you do. That's an interesting inflection point on trust. But it's only when we got a certain level of trust that we can start looking at these feedback loops. We automate them so that we strain trust less. If we have a high level of trust, I can trust that your bug report's probably pretty good. And if I don't understand it, it's my fault. I don't understand it. I will ask you a question. I won't go, can't reproduce, bye-bye, right? And automation sucks a lot of the air out of that. So I can do this with a lower level of trust. But I'm telling you, when you get to a really high level of trust, you're going to get an instant message from a guy going, this isn't working right. And you're not going to be annoyed. You're like, oh, really? And we're going to start collaborating on it. I'm going to pop you on the phone. We're going to work through it. I'm not going to have to use any formal communication because I trust you. If you've got a problem with the system, there's a freaking problem with the system. Let's figure it out. That's what high-level trust looks like. You know, I stumbled on this years ago. I found out that I could never make a high-performance website without a high-performance team behind it. The high-performance team knew each other, trusted each other, believed in each other. When somebody had a concern, we all had that concern. That's what that team looks like. Turns out that was DevOps. Who knew? Okay? The bigger thing is, how do you build these? What were the things that work? And how can the tooling help us move this further forward? Next thing that's going to happen, and this is one of the ways that I built a lot of trust, started having dev guys involved in operational problems. So when we were in production, and it was a Saturday, and you'd done everything that made sense and it still didn't work, you'd call in a dev guy. Adrian Cockcroft actually is quoted as saying, when we started calling the devs at 3 a.m. for outages, we got a lot less outages. But I'm thinking a little more constructively than that. There are ways that developers understand software because they help build it that gives them insight into external behavior, okay? So when we get to a place where we don't know what to do next in operations to get the system back up, having a dev look at it and go, probably a senior resource, maybe it's this. Now, a few things for the dev. Do not write any code during this firefight. It will only make it worse. Ask me how I know. Okay? It's just so easy to go down the road. Oh, I'll just fix it. I'll just bypass all our testing and make some changes to code and check it in. What could go wrong? Don't write code. Use your insight to talk about what's going on in the system. And the byproduct of that process, you go through one or two firefights, the next thing you're going to say is, we just don't know enough about what's going on inside the system in production. We need better instrumentation. You'll start talking about a dashboard. How do I give a tool that ops uses that could test individual parts of the system, that gives us a set of green lights, some gauges, just give a sense of this works, this isn't working, restart just that piece, give me a test transaction end to end and tell me how long it took. Those are all the buttons and knobs you'll add to it. And there's more that'll come once you head down that path. But at the beginning, it'll be that. And one of the interesting things that'll come out of that, by the way, the first time operations ask for a feature in an app, have a party. That's a good day. That speaks to a level of trust. Guys, we're having a problem. I'm willing to tell you about it, and I think you can help me. That's a pretty powerful statement by operations. So it's a good time. Absolutely, let's give that priority because that's going to make all the rest of the software better. And the dashboard is one of the pieces that will come from that. And you'll start talking about metrics. What to measure to really understand how the system works. Now, metrics are a really interesting thing. If you've been demanded metrics before you really got into a DevOps mentality with software, it's probably come from management, which means it's probably vanity metrics. I need happy noises to tell the board. How about the total number of users of the system? Well, seeing how we never delete a user, that number's only going to go up. That's a happy metric. There's lots of good news metrics. But real metrics, actionable metrics, are metrics that you know what to do if it goes up. You know what to do if it goes down. You know how to react to it. And often it's a second or third order metric. So total number of users, not a usable metric. Number of users this month, not a particularly useful metric, or number of users per day. But what about the delta? What's the rate we're adding users? Is it increasing or decreasing? If we're starting to decrease the rate we're adding users, maybe it's time for a new marketing campaign. Right? If it's increasing, what's the activity we're currently doing that's increasing the rate of number of users per day? We got to do more of that. Right? They're reactionable measurements. And ultimately, you'll figure out pretty quickly, they become business metrics. Somehow increasing the number of users increases value to the system. Right? Whatever that system may be. And maybe it doesn't increase value. I deal with a lot of e-commerce systems. So obviously I care about the number of sales we're making, the total sales, but that's not a particularly actionable metric. What's an actionable metric? What is the delta of the average numbers of items being sold per order right now? We're averaging 4 items, but we're going up by 0.1 per month. That's a good number. We're going down by 0.1 per month. That's a bad number, right? Maybe I've got to change behavior. One of the things we found out pretty quickly when we started measuring like that was speed of site affected total sales. So I'm trying to figure out how to get a performance tuning cycle done on this app, which is a terribly hard thing to do. Why? Because performance tuning is not a feature. Nobody cares about performance when you've got it. It's like air. Nobody cares about the air in this room. If I sucked all the air out of the room, you'd care. But the rest of the time, you don't. As soon as it's here, you forget about it. Performance is exactly like that. You do a performance tuning cycle where you put all your guys to make stuff go faster. What do people remember? That's the cycle we didn't ship any new features. So you had to do the math. Own the math. We forget about the ROI of these systems. These systems make us money, right? If they're e-commerce systems, or at least they save us costs. Every system has some influence over the business. Figure out what it is. Because if you can move that number, and if you can show a behavior moves that number, you'll get more money. So I wanted to make the system go faster. I believed it would make more money. So I've got the metrics in place to show that the average size of sale, number of people buying, those are all good numbers. And I'm trying to figure out, now, we're averaging about 6 seconds per page right now. If we went down to 4 seconds, what would that number look like? How much better would it be? But I know that making it 4 was really, really hard. So instead, I added the weight in and pushed it down to 8, which reduced the total number of sales. But now I have a graph. When we're 6 seconds, we make this much per sale. When we're at 8 seconds, we make this much per sale. So logically, if we go 4 seconds, we go that way. Then I showed that to the director of sales, who said, please take away that 2-second delay. That was easy. I just turned that delay back off again. It's like, okay, now we're making more money. But hey, put that in all your code. If I could prove that if we spent $100,000 on a couple of consultants and some performance tuning time, I can get it down to 4 seconds, and it's worth this much a month. We will pay off the cost of that in 3 months. And ever that, it's just gravy. Oh, and hey, you're the director of sales. You actually get a bonus based on how much we sell. Probably pretty incented to move that graph, aren't you? I got my budget, right? We did performance tuning. We got it down to 4 seconds. We made everybody some money. That's a good day. Actually reflecting business metrics. Everybody gets good at this because we're in first way and we're spreading these ideas around. We start focusing on what's actually important to the business. And that focuses in on its second way goals. These feedback information mean we're making software faster, we're fixing performance issues faster. Other stories need to start appearing, and we start being able to control those. Communication's less painful because it's automated in some respects, and trust levels are going up. So we're getting more done. And that opens the door to the third and final way around DevOps, the synergy effect. We have this constant feedback. We know what the software is doing. We know the consequences of our actions. So we can start to experiment. Because you only learn from failure. But we avoid failure right now because it's expensive and time consuming. But as we automate and we accelerate, we can fail very cheaply. We can get fast very quickly. The cost of failure is extremely low. So now we don't have to be right all the time. We can try stuff and we can move faster. A few things that pop out right away. Control over the configuration of buying, control over the package becomes paramount. You can't move fast if it's unreliable. A lot of static analysis and asserts and so forth make a lot of sense because they catch dumb things early so we can move faster. But the most important thing is we know where our technical debt's coming from because all that stuff is visible now. So we start battling it routinely because it actually makes us money. Everything else goes faster. And so we start allocating 1 day a week to it or 1 week a quarter on it, whatever that scale is, so that we're actually knocking it back because we can see the return. There are metrics on all this now. You've got the second way down pat. Technical debt is obvious, and you can nail it to the wall, make it go away, and the software gets better. But the really fun one is that we don't have to pick one right way. Because we can cycle fast, we can build several versions of a feature. Writing code is easy. Testing code's the bear, and deploying it's a nightmare. But if we get all that pain dealt with, I got 2 guys think they got totally different ways to make this particular feature. Build them both and A/B test them. And actually measure the metrics that matter, the business metrics, to say which one's better. Just don't punish the guy who built the one that wasn't as effective as the other, because there's no reason. Failure's how we learn. You only built 2 versions of that? Try 5. Marketing's got this figured out. They A/B test ads all the time. Because when the right ad is right, it's dramatically better from the other ads. Same thing with features. You'll see massive returns when you get the right feature built the right way. And that means it's instrumented, because you can actually measure the difference between them, which means you're probably building it the right way in the first place. Side effects of third-way goals, the synergistic abilities. We start having visibility in our system, so we start building features differently, even anticipating need. You're seeing people hang out on this thing that doesn't quite do everything they need. You can ask the right questions and actually figure out what the next version looks like. What is the stuff that people are focusing on? What's taking too long? What's fast? We can optimize them and manage it quickly. We're a long way away from that destructive cycle we were in just a few slides ago. Right? This becomes really fun because you're working on the problem. The problem isn't you anymore. It's over there. We're watching how the customer uses the app and how they react to it and whether or not it's hitting the returns that matter. And we're experimenting. And when we're wrong, we fix it, move on, move on, and move on. That speed becomes amazingly effective. The fundamentals in DevOps, the essence of DevOps, is that we're just building better software, and it becomes easier to build it, becomes easier to operate it, and you become really responsive to what matters in software, which is the business need that it was mapped to in the first place. You can explore that space in a larger way. Now, if you want to know more, there's a few places to look. There's 5 books here. If you're only going to buy one, buy the first one, The Phoenix Project. This is Gene Kim's book. It's a short book. It's an easy read. It's fiction. Don't read it for the love story. Read it for the story of a company being turned around on good software and software practices. It's inspiring. It gives you some ideas of where to go. Okay? It's a lightweight, relatively easy read. The next book is The Lean Startup, Eric Ries's book. You don't need to be in a startup to read The Lean Startup. And unfortunately, The Lean Startup is horribly hip right now. The Silicon Valley just lives and breathes this book. And it's a good book, but it's not that good. The most useful, there's 2 things that come out of this book that will matter. One is this idea of customer-driven design, that you're looking at how customers react to things even before you build them. You're building the minimal viable product. And that's a really interesting way to think about software, that we can look at how people poke away at things. But the most valuable thing for most organizations is right in the middle of this book is a chapter about how to do startup culture in a bigger business. And so you're thinking about how am I going to get DevOps started and all of the inertia that's around my organization and the belief in the current systems flow. That chapter will give you some hints about how to present a radical idea, being I want to change the way we build software to actually make it better, which apparently is a radical idea. Lean Startup will help you with some ingredients culturally to put that into work. The other 3 books are all very good books. Gene Kim's book on visual ops falls firmly on the operations side of things, how we make ops that people understand and can appreciate. Because all too often what we're doing is wizard work and nobody understands why it's hard or what it's easy. Allspaw's book on web operations is also somewhat ops-centric, but very focused on the web side of things. There's a big developer engagement in it. And continuous delivery is Jez Humble's book on how to get to the continuous delivery point. Those are 3 really beefy books. They're well worth your shelf space. If you're ready to tackle any of those issues, they're worth a read to move forward. With that, thank you so much for your time. I appreciate that you stuck around. We started a little late. And if I can answer any questions, I'm happy to do you. Thank you. That or I need a beer. One of and do a beer. It's getting wet. As I said, we had about 2 hours where the AC would give up on us, and I think we went an hour and a half. So we're at the, okay, that's it for the AC point.